The Earth has spoken. Its voice is thunderous, ancient, and impossible to ignore. In a single moment, the world is reminded of the raw, untamed power that lies just beneath our feet, waiting for the right moment to break through the surface. Today, June 11, 2025, a massive plume of ash and steam erupted from Mount St. Helens, shattering decades of uneasy quiet. The mountain, long considered dormant by many, has awakened with a force that commands attention. This is not a drill. The warnings are real, and the consequences could be far-reaching. It's a geologic event with global implications, sending ripples of concern across continents and reminding us how interconnected our planet truly is. For those who remember 1980, this new activity is chilling, a stark reminder of the immense power that slumbers beneath us and how quickly it can awaken. The eruption, though moderate for now, has sent shockwaves through the scientific community. Researchers are scrambling to analyze data, searching for clues about what might come next. Why? Because Mount St. Helens is part of a vast, interconnected system of geologic stress, a chain reaction waiting to happen, stretching across the Pacific Ring of Fire. The awakening of one volcano can signal unrest in others. The Earth's systems are linked in ways we are only beginning to understand. The world is watching, holding its breath as scientists and officials try to understand what this means for the days and weeks ahead. The immediate danger is clear. Ashfall threatens air travel, infrastructure, and public health. Communities nearby are bracing for disruption, and emergency plans are being put into action. But the greater concern is what this eruption signifies about the region's geologic pressure. Is this just the beginning of a larger event? The Earth's crust is a mosaic of tectonic plates always in motion, grinding and shifting in a slow, relentless dance that shapes our world. This eruption is a warning sign, a geologic exclamation point, urging us to pay attention to the forces at work beneath the surface. The data we gather now will help protect lives, inform future decisions, and reveal what might come next in this unfolding story. This is a time for science and preparedness, not panic. Communities must stay informed, and everyone must be ready to act if needed. Mount St. Helens is telling us a story about the deep, fiery engine that drives our planet. We must listen and learn from what it has to say. The universe's power is on full display, right here, right now. Nature's might is both beautiful and humbling. This moment will be studied for generations. It will inspire new questions, new research, and a deeper respect for the forces that shape our world. The mountain is not just erupting, it's communicating. Its message is urgent, and it is up to us to interpret its signs, and we must pay attention. The story of Mount St. Helens is still being written, and we are all witnesses to its next chapter. Mount St. Helens is not alone. It's part of the Cascade Volcanic Arc, a chain of active volcanoes stretching from California to Canada. This arc forms the backbone of the Pacific Northwest's dramatic landscape, shaping the region's history and its future. These peaks, including Rainier, Hood, and Shasta, are siblings in a massive geologic system. Each one is a sentinel, standing watch over the land, and each has its own story of fire and transformation. Their existence is driven by subduction. The Juan de Fuca plate dives beneath North America, melting and feeding magma to the Cascades. This slow-motion collision of continents is the engine behind the region's volcanic power. An eruption at St. Helens is a release of pressure from this system, a dramatic reminder that the Earth beneath us is alive and restless. The 1980 eruption was the deadliest in U.S. history, flattening forests, destroying homes, and sending ash 15 miles high. It disrupted lives hundreds of miles away, darkening skies and halting air travel. It transformed our understanding of volcanoes, showing their violence and unpredictability. Scientists learned that even a quiet mountain can awaken with little warning, changing the landscape in moments. When St. Helens stirs, it's not just a memory, it's a present and future danger. The volcano remains active, reminding us that the threat is ongoing. This new eruption is a critical data point in the ongoing story of the Cascade Arc. Every tremor and plume adds to our knowledge, helping us prepare for what might come next. Scientists are asking, is the entire subduction zone becoming more active? Are we seeing the start of a new cycle of eruptions? Is stress building at neighboring volcanoes like Rainier? Could one eruption trigger another, setting off a chain reaction across the arc? The eruption is a reminder. These beautiful mountains are also gateways to unimaginable power. Their serene appearance hides the forces that shape continents. The stakes are high for the entire region. Millions of people live in the shadow of these volcanoes, and their lives could change in an instant. What happens to one volcano can affect the others. The Cascade Arc is interconnected, and a disturbance in one part can ripple through the whole system. The Cascade Arc is a living, breathing system, constantly shifting and evolving. Its story is still being written. Every eruption is a message from deep within the earth. We must heed it, learning from each event to better protect ourselves. Our safety depends on understanding these signals. By listening to the volcanoes, we can prepare, adapt, and stay one step ahead of disaster. How can an eruption in Washington affect a volcano in Wyoming? At first glance, these two mighty volcanoes seem worlds apart, separated by hundreds of miles of forests, mountains, and plains. But beneath the surface, they are more connected than you might think. The answer lies in the immense tectonic plates that make up the Earth's crust. These plates are vast, stretching for thousands of miles, and when stress builds up in one area, it can travel great distances through the interconnected crust. Imagine cracking ice on a frozen lake. The force of your action can send ripples and create new cracks far away from where you started. The stress doesn't just stay in one place, it spreads, sometimes unpredictably. The Earth's crust works in a remarkably similar way, transmitting energy and stress across vast regions. A major eruption like Mount St. Helens doesn't just release ash and lava, it unleashes enormous stress, altering the stress field across the entire continent, sometimes in ways we can't immediately see. This sudden release of energy can trigger activity elsewhere, sometimes even at great distances, setting off a chain reaction of geological events. Scientists now worry that the pressure released at St. Helens could transfer east toward Yellowstone, a region already under immense geological strain and closely monitored for any changes. Yellowstone is especially sensitive, trembling with thousands of small quakes each year, each one a reminder of the restless forces below. The fear is that this new jolt of energy could disturb Yellowstone's delicate underground system, potentially leading to increased volcanic or seismic activity in the region. The eruption at St. Helens has triggered a continent-wide investigation, with scientists racing to understand the shifting patterns of stress and what they might mean for the future. We're not just watching one volcano, we're watching a network, a vast system of interconnected giants whose fates are intertwined. The alert for Yellowstone is based on careful scientific analysis, not certainty. It's a warning grounded in data, but the outcome remains unknown. The chain of events has begun. A plate subducts, a volcano erupts, and now, pressure may be building beneath one of the world's largest volcanoes. The stakes are enormous, and the consequences could be far-reaching. We must stay vigilant, watching and learning from every tremor and every sign the Earth gives us. Yellowstone isn't a mountain. It's a supervolcano, capable of eruptions 1,000 times larger than St. Helens. Its caldera spans 30 by 45 miles, hiding a colossal magma chamber beneath the surface. Old Faithful is just a vent for this slumbering giant. Yellowstone's past eruptions were planet-altering, covering North America in ash and plunging the world into volcanic winter. An eruption today would be catastrophic. While a super-eruption is unlikely in our lifetime, any change in Yellowstone's system demands attention. More likely are smaller but still dangerous explosions or lava flows. The connection to St. Helens forces us to consider worst-case scenarios. Yellowstone is complex and high stakes. The recent Cascades eruption reminds us, this beast is only sleeping. We've just heard a noise that might disturb its slumber. The world is watching. Science is our only warning. We must not ignore it. What is a volcano? Simply, it's a rupture in the Earth's crust, letting magma, ash, and gases escape. Picture a shaken soda bottle. Magma is the soda, the crust is the cap. If pressure builds or the cap weakens, eruption follows. Magma forms deep within the Earth, rising because it's less dense than surrounding rock. It collects in chambers, sometimes for thousands of years. Eruptions begin when pressure overwhelms the rock above. This can happen if more magma enters or if an earthquake fractures the crust. When magma reaches the surface, it's called lava. The most dangerous eruptions are explosive, driven by volcanic gases expanding violently. This shatters magma into ash, sending clouds miles high. Both St. Helens and Yellowstone have this explosive potential. That's what makes them so dangerous. Understanding this is key to our survival. How do we defend against such power? We watch, measure, and listen. Today, networks of instruments monitor our most dangerous volcanoes around the clock. The USGS and its observatories are our sentinels. Seismometers detect tremors, often the first sign of magma movement. GPS stations measure ground swelling, a sign of rising pressure. Gas sensors track changes in volcanic emissions. Thermal cameras spot new hotspots from the air or space. All this data streams to scientists who look for patterns and warning signs. Their alerts are based on careful analysis, not guesswork. It's a high-stakes detective story, trying to predict the next move of a restless Earth. Their vigilance is our best defense. Science gives us time to act. We must trust the data. For millions living near volcanoes, warnings are life and death. Preparedness is a partnership, scientists, officials, and citizens working together. The goal: mitigate effects and save lives. Emergency plans are based on hazard maps with evacuation routes and shelters ready. Drills and public campaigns ensure everyone knows what to do. Communication is key. Alerts go out instantly via TV, radio, and phones. Schools and businesses have their own plans. Farmers protect livestock and crops. The memory of 1980 keeps the region vigilant. For families, preparedness means having a kit and a plan. N95 masks, goggles, and sealed windows are crucial in ashfall zones. This isn't paranoia, it's resilience. Being ready saves lives. What's the message from scientists? Heightened vigilance and caution. The Mount St. Helens eruption has changed the risk landscape for the West. Yellowstone is now under heightened advisory. This isn't doom, it's a data-driven warning. The public should rely on official updates from the USGS, not rumors. The USGS uses a color-coded alert system. St. Helens is at high alert, Yellowstone at advisory. Near St. Helens, the hazards are ashfall and possible pyroclastic flows. For the rest of the country, watch for earthquake swarms or changes at Yellowstone. Scientists will communicate any signs of instability immediately. This is the last warning before crisis management begins. Warnings are meant to enable action, not incite fear. Science gives us the ability to read the signs. Ignoring them would be dangerous. The mountains are speaking, we must listen. We live on a restless planet. The eruption of Mount St. Helens and the Yellowstone Alert are reminders of Earth's power. Volcanoes shape our world, creating land, soil, and even atmosphere. They are both creators and destroyers. Our journey has shown how volcanoes are connected by immense forces. Science turns fear into understanding, giving us a fighting chance. More eruptions will come, we cannot stop them. What we can do is watch, learn, and listen. Support scientific research and heed emergency advice. Our resilience depends on respecting the planet's power. The universe isn't obligated to keep us safe. Today's events are a lesson in humility. Let's listen to the Earth, not with fear but with respect and curiosity. Science translates the planet's roar into wisdom we need to endure.